In today's lesson, we are going to be looking at compound interest. In the previous lesson, we looked at compound interest and simple interest and how they compare, and we calculated compound interest using a table, right? But rather than using a table, because that can be time consuming to find out year after year, and we really only want to know the final amount, we can use a formula. So our compound interest formula is the one we see here. A equals P times 1 plus I all to the power of n. Now, some of these variables are similar to the ones before. A is the total amount of the investment, or we can consider it now the future value, how much we're going to have in the future. P is the principal, or the present of value, or the initial amount. I is the interest rate as a decimal, but what's new now is that it's per compounding period. And n is the total number of compounding periods. All right, so we have two different things here in this formula. So aside from it being a different formula, we do have two small things that make it a little bit different. And when we're dealing with compound interest, we need to start dealing with some different terminology because it affects what we're doing. So in our compound interest questions, when we're trying to calculate compound interest, we might be told some of these terms: annually, semi-annually, quarterly, monthly, bi-weekly, weekly, and these are compounding periods. Right? So this tells us how many times we're calculating interest over a year. So annually means once a year. Semi-annually means 2 times a year. Quarterly means 4, monthly 12, bi-weekly 26, and weekly 52. You could also have daily, which is 365, but you get the idea. So when we're dealing with compound interest, we're going to usually be told when we're calculating the interest, or how often we're calculating the interest a year. What that means is, though, now, if I go back up to my formula for I, it says interest rate as a decimal per compounding period. So for when I have my interest rate, not only do I have to turn it into a decimal, I have to figure out the interest per compounding period. And your questions or scenarios are only ever going to give us the interest rate per year. So to calculate it for per compounding period when it's annually, we have to divide it by 1, or it doesn't really change. If it's semi-annually, we have to divide it by 2. Quarterly, we divide it by 4. Monthly, divide it by 12. Bi-weekly, divided by 26, and then weekly divided by 52. So basically we're dividing up our interest, or the rate, divided by what our compounding period is. For our term, the total number of compounding periods, what we do is we take our years and multiply it by the compounding period. So if it's 1 year, in years, we multiply it by 1. If it's semi-annually, we take our years and we multiply it by 2, because that would be 2 compounding periods for every year. Quarterly, we multiply by 4. Monthly, we multiply by 12. Bi-weekly, we multiply by 26. And weekly, we multiply by 52. And we'll do some of those calculations, and we'll look at this more in depth when we look at the actual formula and some questions. So in the first example, we just want to calculate the I, or our interest rate per period, as it would appear in the compound formula. And we're going to look at 3 different scenarios. So one is 6% semi-annually. So we said before it needs to be as a decimal, so I need to take the 6%, divide it by 100, and get 0.06. So that means that the interest rate per year is 6%, but because it's semi-annually, we want to figure out, okay, semi-annually means twice a year, so I want to figure out what is the interest rate per each half of the year. So what we do then is we take the 0.06, we divide it by 2, and this will be for our I value, and we get 0.03. or 3%. So that means that 6% per year is actually broken up into 2 3% segments, I guess you could say. If I have 5% weekly for B, again, we want to convert it to a decimal. So 5% becomes 0.05. And because it's 5% for the year, but compounded weekly, I have to take that 5%, divide it by 52 to basically determine what is the amount of interest earned every week. Here we get 0.00096. So a very small amount of interest every week, but over a full year, it will add up to 5. And lastly, 1.75% quarterly. So we take the 1.75%, turn it into a decimal, 0.0175. So that's what it is per year. But because it says quarterly, I need to take that value, divide it by 4 to figure out how much interest is being, or the percentage of interest that is being earned or owed each quarter. And we get 0.0044. So I'm just going to round it there. So you might get some very small numbers, which is okay, right? Because usually if we're taking relatively small numbers to begin with and dividing them, right, you're going to get small numbers, you're going to get decimals. So it's okay if we get this. Be careful with your rounding, right? I always like to keep 2 actual values other than 0. But again, how you calculate and round is up to you, but try to keep as many decimal places as possible. So that's an example of just calculating our I value, right? We haven't calculated interest yet. We haven't determined how much money we're going to have or anything like that. All we did was just calculate the I value. In example 2, all we're going to do now is do the same thing, but we're going to be looking at calculating the N value. So this is something that we have to do as well before we even begin our compound interest formula. So in the first one, compounded quarterly for 5 years. So that means quarterly means 4 times a year. And if we're doing it for 5 years, our N value is going to be 5 years times 4 times a year, or 20. That means there are 20 compounding periods, 20 times over the length of the 5 years where we would be earning interest. For B, semi-annually means 2 times a year for 18 months. In 18 months, we need to convert to years. So similar to our simple interest, 18 months, we can divide that by 12, or we would get 1.5 years. So if it's semi-annually for 1.5 years, we're going to do, our N value is going to be 2 times, we keep a consistent number of years. So 1.5 years times twice a year, and we get 3. That means there are 3 compounding periods over the length of that loan or whatever it happens to be. Biweekly, 26 times a year for 2 years. So our N value is going to be 2 years times 26. We get 52. So that means over the 2 years, there would be 52 times where we're calculating interest. So now let's look at a formula. Let's look at an example where we're actually using this formula. So determine how much money you will have if you invest $500 at 4% per annum for 6 years. So I'm still going to write out my formula A, P, I, and N. A is the future amount. We don't know what that is because we're trying to figure out how much money we will have. P is our principal, so what we're investing, so $500. Our interest rate, it says 4% per annum. Per annum is a new thing. We haven't really seen that before, but per annum means per year. So in our questions, we're always going to be told how much interest or the interest rate per year, but then we are going to be told compounded by a certain period. So compounded semi-annually. Semi-annually means 2 times a year. So that means when I calculate my I value, I'm taking that 4% as a decimal, 0.04, and I'm dividing it by the compounding period, which is semi-annually or twice a year, to get 0.02. N, number of years, is 6 years. But remember, we do have to do another calculation. It's 6 years, but compounded semi-annually, so twice a year for 6 years, or 6 times 2, and we get 12. So we do have to do these two small calculations first before we can actually use our A equals P times 1 plus I to the power of N formula. Once we have done those two calculations for I and N, we can go through, calculate our P value. So 500 times 1 plus 0.02 to the power of 12. And we can go through and calculate this all at once. And we should get 634.12. So now that is how much we're going to have after 6 years. So with this formula, we don't need to add anything to a certain value or anything like that. We're already being told the final amount after the 6 years. So everything included, the interest and what we started with, we're going to have $634.12 in our account. Example 4, Amy borrows $500 or $5,000 to buy a car. She agrees to pay it back at the end of 4 years. If the interest rate on the loan is 6.5% per annum or /A, compounded quarterly, how much will she repay at the end of the 4 years? How much interest does she pay? So again, I'm going to go through A, P, I, and N. I know I'm using these variables now because it says compounded in the question. So when it says compounded, I know I'm going to be using a different formula that's not the simple interest formula. So that's why I'm using these letters instead of the I, P, R, and T from the last one, or last lesson, or from a previous lesson. So I'm going to go through. I don't know the future amount. That's what we're trying to calculate. The principal, what we start with. So she's borrowing $5,000. That's what she's starting with. The I, we know, or let me highlight at least the 5,000. The I, we know the 6.5%. The /A, that just means the per annum, so 6.5% per year. Remember, we do have to do a small calculation. So I have to take that 6.5%, turn it to a decimal, 0.065, and divide it by the compounding period. It is compounded quarterly, which means 4 times. Let me just make it a little nicer. So 0.065 divided by 4. Get 0.01625. I'll keep those decimal places. So that's how much interest it is per quarter. And again, 4 of those would add up to the 6.5% per year. N, total number of years, well, it is 4 years, but because it is compounded quarterly, 4 years times 4 times a year, we are earning interest or owing interest, or calculating interest 16 times over that 4 years. Now I can use my formula, P times 1 plus I to the power of N, 5,000 times 1 plus 0.01625 to the power of 16. This is now a calculation that we can plug into our calculator all at once, again, depending on our calculator, but it should be fairly straightforward if we have a good scientific calculator. we end up with $6,471.11 or $6,471.11. And that is how much we're going to owe at the end of 4 years. Now, the second question asks, how much interest does she pay? So here we kind of have to do the opposite. I know the total amount. So my interest is going to be my future amount or my final amount minus my principal. So 6,471.11 minus 5,000 equals $1,471.11. So that means after 4 years, we would owe an extra $1,471.11. So we're owing the 5,000 still originally plus this interest now. Last example, same idea. We're just getting used to using that formula. Jamal invests $3,000 in a GIC that pays 2.4% per annum compounded monthly for a term of 10 years. How much will he have at the end of the term? So again, A, P, I, and N. Because it says compounded, so we're using the compound interest formula. Future amount we don't have, that's what we're trying to calculate. Principal, we're starting with $3,000. The I, or the interest rate, is 2.4% per year or per annum, but compounded monthly. Monthly means 12 times. So I have to take that 0.024, divide it by 12, because if it's 2.4% per year, I want to know what is it per month. Dividing by 12, we get 0.002. And then N, the length or the number of compounding periods, it is 10 years times 12 months in a year, because it's compounded monthly, or 120. I now have all my information. I can plug it into my formula. 3,000 times 1 plus 0.002 to the power of 120. And we would have $3,812.83 for our new amount at the end of 10 years. So again, you might say that's not a lot of money after 10 years, $812. But again, you're not doing anything, right? A GIC is what's called a guarantee, or I think a guaranteed investment certificate or something along those lines. But basically, you're guaranteed a certain percentage over the course of a year. So sometimes when you're saving, there is a risk, depending on what you're saving your money in, that you might not earn a certain amount or you might not earn a certain percentage. With a GIC, you're guaranteed to earn that percent. So I'm guaranteed to earn 2.4% each year. Right? So you're not really doing anything in this, right? You're just putting money in and you're letting it work for you, right? So again, it might not seem like a lot, but the fact that you didn't have to do anything kind of means it's basically like free money. Yeah, you have to wait for it, but in the end, like I said, you're not doing anything for it, so it's not too bad. So this lesson is just looking again at the compound interest formula. It is different from simple interest. We do have to do two calculations before we can actually calculate, right? We do have to find that I and that N, and that is dependent on what the compounding periods are. But again, look for the word compounded in your question, and then look for one of these compounding period terms that should hopefully help you figure out or calculate those values and then go on and find the future amount.